फर्स्ट ऑफ ऑल गुड मॉर्निंग, गुड आफ्टरनून एंड गुड इवनिंग टू एवरीवन जिन्होंने हमें ज्वाइन किया, चाहे वो पाकिस्तान से हैं या पाकिस्तान से बाहर से हैं। और सबसे पहले तो मैं आपको वेलकम करना चाहूँगा प्राइस सिस्टम्स वेबिनार सीरीज में। दिस इज़ आवर सेकंड वेबिनार। दिस इज अ सीरीज ऑफ वेबिनार्स जिसमें हम एक्सपर्ट्स को अराउंड द ग्लोब कोशिश करते हैं कि वो हमें ज्वाइन करें और अपना एक्सपीरियंस और अपनी नॉलेज शेयर करें। ठीक है, इस वेबिनार के बारे में आपको बताना चाहूँगा। ये वेबिनार किस बारे में, इट्स अबाउट स्मार्ट कॉन्ट्रैक्ट हैकिंग, ये होती क्या है और इसकी वेनेबिलिटीज और एक्सप्लॉयटेशन को थोड़ा डिटेल में देखेंगे। तो ये और इसका ओवरव्यू ये है, इट्स अबाउट स्मार्ट कॉन्ट्रैक्ट हैकिंग। एंड जो हमारी एप्राइज सिस्टम वेबिनार सीरीज है, इसमें हमने रिसेंटली क्लाउड सिक्योरिटी का एक वेबिनार किया है, और दिस इज स्मार्ट कॉन्ट्रैक्ट हैकिंग अबाउट ब्लॉकचेन टेक्नोलॉजी। एंड अपकमिंग वेबिनार इज अबाउट गवर्नेंस, राइट? सो लेट्स क्विकली जंप इनटू आवर टुडेस टॉपिक, दैट इज स्मार्ट कॉन्ट्रैक्ट हैकिंग। थोड़ा सा इसके बारे में मैं बताऊंगा, देन हमारे होस्ट बताएंगे, देन मैं अपने अपने आप को भी इंट्रोड्यूस करता हूँ। Okay. First of all, I'm Ali Hassan Gori and I will be your host for today's session, inshallah. और let's hang tight, so inshallah मजा आएगा। Smart contract basically are self-executing programs that runs on blockchain platforms. Uh, they are meant to be secure but and tamper-proof, but as we have seen in the recent years, ये बहुत सारे अटैक्स हुए हैं, और स्मार्ट कॉन्ट्रैक्ट हैकिंग के जो एक्सप्लॉयटेशन है विनेबिलिटीज की, वो इन प्रोग्राम्स में हुई है, जिसमें हमारे पास बहुत सारा फाइनेंशियल लॉस है, डिजिटल एसेट की स्टीलिंग है। सो इसी को मद्देनजर रखते हुए, और ये बड़ा एक टॉपिक है जिसके बारे में बहुत ही कम देखने को मिलता है इंटरनेट पे, बहुत ही कम रिसोर्सेज है, तो हमारे पास एक्सपीरियंस ब्लॉकचेन सिक्योरिटी रिसर्चर मौजूद है आज, जो हमें इस बारे में बताएंगे भी, और थोड़ा डिटेल में कोशिश करेंगे कि प्रैक्टिकल डेमो भी दे सके। सो let me introduce our guest. Our guest today is Waqar Ahmad, an experienced blockchain security researcher with expertise in smart contract auditing and tracking. Waqar has conducted numerous successful attacks on smart contracts and helped various organizations securing their blockchain and help them in remediation those vulnerabilities. So first of all, thank you, Waqar, for joining us today, and to our all people जो जिन्होंने इस webinar को join किया है. We are really looking forward to have a great session with Waqar today, inshallah. So without further ado, I would like to invite Waqar Ahmad Fasihi to take this stage and begin his presentation. So Waqar, over to you.
Thank you so much, Ali. Am I audible?
Yep, very much.
All right. Thank you, everyone, and thank you for joining for the today's session. As Ali mentioned, we are going to learn about what are smart contracts and what are the security vulnerabilities associated with them, and hopefully try to see how they can be exploited on a platform. But before we start, I'd like to briefly talk about what a smart contract is. So basically, you might have heard about cryptocurrencies. You might have even exchanged some of it. So what happens is cryptocurrencies are one example of the utilization of blockchain technology. And what blockchain is basically is a different topic. But basically, the programs are executed through smart contracts, and usually they are written in a programming language known as Solidity. Some other programming languages are also there, but mainly Solidity is used. And in layman terms, the blockchain technology is named blockchain because each transaction becomes a block of or gets connected to the previous block, and all those blocks with every transaction are linked together in some ways similar to the linked list we might have learned in programming language, and therefore they are called blockchain technology. So with that brief introduction of blockchain and smart contracts, as Ali in the field of information security for almost 10 years. in various domains such as API security, web security, mobile app security. And most recently, I've been trying to polish my skills in blockchain and smart contract security. Some of my talks have also been featured in SANS, Hackfest, and the Hack Summit in Poland. I was also instructed with Cybery. So that is a brief introduction of myself. I try to share my knowledge on my YouTube channel as well. All right, so further details into the features of smart contract. So what makes people shift towards blockchain or towards smart contracts? So basically, in a banking transaction, when you purchase something, let's say you do an online transaction and you make the payment through your credit card or debit card, what happens is it goes to a third party, which is the bank, and then it processes your payment, and then it transfers that amount to the seller. So there is a middle party involved, which can regulate your finances. And in worst case scenarios, it can also block your finances. But in the case of smart contracts, there is no third party involved. You can consider it as a vending machine in which you put some money and you get a product in return. So there is no person, or there is no, you can say, blocking of anything. You just put the money, the amount is shown, and then you can buy whatever you like in that amount. So that is one feature of blockchain or smart contracts, that there is no middle party involved. And then the second feature is that it is both transparent but anonymous. So that it might be a bit confusing, but when we say transparent, it means that every transaction is available for everyone to see. And that is how it becomes part of the block. Only when certain parties approve the transaction and calculate the hash, only then it can be made a part of the block, which makes it transparent or visible to everyone. The anonymous part of it is that the only thing that the people can see in a contract being executed is your address, your wallet address, not your actual address, your wallet address. And that is the only thing that is being shown. Your name is not displayed, your further details are not displayed. The only thing that people can see is your wallet address. So that makes it anonymous, but at the same time transparent. And we are going to look at that in just a moment. And the third thing is that it cannot be reversed, or once a transaction is made, it cannot be modified. What that means is, once a transaction has taken place, let's say someone transferring money to someone, or someone changing the ownership of something, once it becomes part of the block, it cannot be modified. Let's say if someone transferred $20, it cannot be later transferred that $15 were transferred or $25 were transferred. So that makes a good way of fraud prevention. And that feature of it also makes it unique. So just to recap, similar to contracts in the physical world, in which a buyer sends a commodity. It can be a cryptocurrency, any sort of currency, it can be money, and then the seller can give back a commodity in exchange. It can be another cryptocurrency, can be the ownership of something, or it can be an NFT, which we are seeing today. So it can be anything the seller might be transferring. The only thing is that instead of physical contract is executed, and through that digital contract, either a transfer of fund takes place or transfer of ownership takes place. And it can also be automatically executed in the sense that certain terms and conditions can be configured, and once those certain terms and conditions are true, the contract will be executed. So for example, in future trading in crypto currencies or wallets, you set a certain criteria. For example, once a currency goes above, let's say $100, when it is on 90 or something, a certain trade will take place. So that is an example of automatically executing a contract. So with that, let's talk about why it is necessary to secure those smart contracts. So the problem is that a huge sums of money is being transferred or traded on, especially on crypto exchanges. And if a hack takes place, considering that it is relatively a new technology considered to compared to web technologies, the vulnerabilities are still being discovered, and the margin for error is very low because a lot of hackers are trying to exploit those vulnerabilities. And since the technology has not revolutionized completely, those vulnerabilities are still existing, and slowly they are being mitigated. But while that happens, the hack can result in loss of millions of dollars. And just two of the attacks that took last year, one was the Poly network was about 2 years back, but last year one was on Binance and the other one was FTX. Allegedly it was a hack, but just those two hacks resulted in a loss of about 1 billion or more in funds. And 2 years before that, there was another attack that was amounting to $600 million. So when a website is hacked, or even when a bank website is hacked, the highest amount is stolen from it is somewhere around $30 million. So you can imagine the impact is far more on crypto exchanges or on technologies based on blockchain and smart contracts than compared to web technologies, although that cannot also be ignored. So this is a huge arena for both the hackers and the security researchers, because uh, there there are some companies that pay very well for identifying vulnerabilities in smart contracts, and one of those vulnerabilities were paid a bounty of $1 million. So not only is it an opportunity for hackers, but also for security researchers, which is why we are discussing it today. So one of those companies that has conducted somewhere around 100 audits of different smart contracts, or you can say some of them were security exchange companies. They compiled the vulnerabilities, and I got this graph from their website. And this is a representation of the percentage of vulnerabilities that they found on those smart contracts. So just like in, you can say in OWASP top 10 for, let's say, web applications, there are some vulnerabilities that are more available than others. So similarly, there are some vulnerabilities that exist more than others, and some might have low impact, or the risk level might be high whilst others might be low. And that risk level, as you might know, is not only just about the impact, but also about the ability to exploit it. Some might be very easy to exploit, and some might be a bit difficult to exploit. So according to this company, around 28% is logical errors in the code. By logical errors in the code, we mean variables not being initialized, or 20% is unauthorized access. Unauthorized access means, for example, things that can be done which only the owner of the contract should be doing, storing private data that might be the wallet addresses being exposed on the smart contract, integer overflow, for example, setting a a limit of an integer of, let's say, 256 bits, and then not putting input validations. What happens if someone puts an integer that is more than that? Gas overflow, that we'll discuss later. But reentrancy attack, which is you can see is around 16%, is something. And one of the attacks, which was polynetwork attack that we were discussing, which resulted in around $600 million worth of money being hacked, was possible due to the reentrancy attack. And the problem with reentrancy attack is that it is very, very easy to exploit. So what are the platforms that we can use? So we are going to learn more about reentrancy attack, and I will try to show you it on a platform if time permits. So let us look at reentrancy attack in more detail, because this is something that has been found in a lot of contracts and easy to exploit and can result in a lot of problems. So I'll try to give an example of a normal banking transaction. So consider that someone transfers $10 into my account from his account, and his account had, let's say, $100. And what should ideally happen is, once the $10 are transferred to my account, his account should be updated and show $90. And this is what is meant to happen. But what happens is, and since a smart contract or blockchain works a bit differently, a person can request transfer of funds, not just someone sending it. For example, I can send a request to someone to send me $10. And if the person authorizes it, the fund will be transferred. So let's say the request that I'm sending is a smart contract, and it is a bit malicious, and we will refer to it as a malicious contract. And there was another attack in 2021, which resulted in $30 million, and it was known as the Dow attack. And this was caused due to the reentrancy attack. So we'll see how it was done. So basically, as you can see, a malicious contract initiated withdrawal, and a withdraw balance function was called, which we will look in a moment. A withdraw balance function was called in the smart contract, and the ethers were then transferred, or whatever currency. In this case, it was ether. And what should ideally have happened is that the update balance function should have executed and updated the balance. But what happened was, the fallback function with the withdraw balance function being called again was executed, and this kept on happening on loop until all the funds were transferred to the malicious contract. So this is the theoretical explanation of how reentrancy attack works. Now let me show you the things we discussed. For example, smart contracts are visible to everyone. So I'll just show you how that works. Let me just open a, let's say, I'll just share my screen and show you. Can you guys see my screen?
Yes, we can see.
Right. So this is basically etherscan.io website, and on it you can see all the transactions that are taking place in the market. So let's say this is a transaction, and we click on it. And can you guys see this website, right? This is the web screen that being shared of Etherscan.
Yes, it is visible.
All right. All right. So I clicked on a particular transaction, and you can see the transaction hash, and you can see the from address, and you can see the to address. Sometimes the ID is also shown, but that is not necessary. And the value in Ether is shown, and the dollars that it was approximately equal to is shown. Then there is the transaction fee, which is also known as the gas fees. And if I want to see what was the contract that was being executed, if I click on verified contract, and I click on, so there are transactions which I can see, which I just showed. And when I click on contract, I can see the actual contract that was being executed, or the part of program that was used to execute that transfer of funds. So you can see that it is written in the programming language Solidity. And what were the modules that were being executed as part of this transaction or contract. So you can see the different modules, for example, aggregator, ownable, ERC20, etc. And all these modules have different functions. So just like in a software, there are different modules that are executed according to the functions. Uh, these are the different modules that are part of this smart contract. Now, this is the part where we can see the transparency of smart contracts. The flip side of it is that anyone can use or copy this contract and research it and find vulnerabilities. And how can someone do that? So I'll try to find a vulnerable contract that was already found. So this is a vulnerable contract with reentrancy attack vulnerability. So I'll just copy it. And then there is a, you can say a platform. For example, let's say there is Visual Basic for other sort of program writing or software development. This is a platform on which you can develop and test smart contracts, known as Remix. There are other uh, platforms as well, but what happens is it gives you a simulation of the mainnet. A mainnet is basically the blockchain on which, once your contract is hosted, it becomes part of the mainnet, which means anyone on the internet can interact with it. So I'll copy and paste my vulnerable program into this. So let us just use the workspace. And then I'll paste the program that I copied, and it gives me a warning. And then I will compile this. All right, seems like it has compiled without any errors, but sometimes it will give you errors. For example, it might say, let's say the version is not latest or is not compatible. So you might just need to change this number if any such errors occur. There might be other errors as well, but I'm just giving you an example. Apparently, this one has been compiled. So once it is compiled, I'll go to this part where it says deploy and run transactions. So first of all, we select the environment. So the environments that you see here are simulated environments, which means these are not the actual mainnet environments. And then I'll select any of the accounts. So these are also dummy accounts, which I can use to show anything. And then there is gas limit, and then there is value, etc. So first of all, I need to deploy a contract. So before I go, so there are, you can see two types of contracts that I can deploy. I'll deploy the Ether Vault contract first. This one will be actually, okay, I might need to select the right currency or set the amount here. This should be smooth. Not sure why this is giving an error. Oh, this is not required. This is a bit unexpected. This should not be happening. Okay, there's apparently some error in the deployment of the contract, but I'll walk you through the contract and why it is vulnerable. So if you see the contract, it says uh, the constructor, the receive part, and the attack part. And the problem over here is that there is no update balance function. For example, the receive part says if address is whatever it says over here, and then the ether wallet withdrawal, and it does not mention, let's say over here it should have been update balance and whatever the requirement of that should have been. But since this is not present, what happens as a result is the the loop goes on and the entire wallet gets drained. Let me just look at the contract and see if anything is that should have been mentioned is missing. This should have worked. All right, so this is the reason for the re-entry attack. The other aspect is the ownership transfer attack. Let me just come back to the slides. So the another type of attack is the unauthorized access attack, which means the ownership of entire wallet is transferred to someone else. And an example of it was in 2017, in which a wallet, the entire exchange was the ownership of it was transferred to someone else, and around 513,000 ether was transferred. And the amount at that time was also in millions of dollars. The other type of attack is buffer overflow attack, which we saw, and that what happens is the amount is or an integer is set a value 256 bits or something like that, and if anyone enters more than that, or let's say for example on a petrol station the lowest you see is 000, but what happens if someone says 11 minus 10? That would result in 0 being flipped and the integer before that, and on a rotating dial the number before 0 is 999. And that is an example of how things in buffer overflow in case of smart contracts work. We can have another session on which we can go through the practical aspects of how to exploit these vulnerabilities, which we are short of time. So I'll just end or pause over here and take any questions that anyone might have. Ali, over to you.
Yes, first of all, thank you so much for that informative and engaging session. It was really excited and very useful information you have shared with us. So very energetic. Thank you. So let's get any questions. We have 4 minutes remaining. So if you guys have any questions, you can share it within the chat box. Anyone?
Oh,
So we
I'll
can
just
wrap up the
like
session.
to mention, if anyone wants to practice, so there are a few platforms for, so for example, in the case of websites, there is Try Hack Me or Hack the Box. So similarly, there are a couple of platforms you can use for the practice of smart contract hacking. So one is Damn Vulnerable DeFi, in which there are vulnerable smart contracts, just like in Damn Vulnerable Web App. And then there is Catch the Ether, uh, in which it's like capture the flag activity, in which you find vulnerabilities and report the flag, and that way you can polish your skills or learn how to hack smart contracts.
So we have a question. What are the steps or procedures to reduce smart contract vulnerabilities?
Let me just see. What are the steps or procedure to reduce smart contract vulnerabilities? Right. So first of all, as I mentioned, there are some well-known vulnerabilities. For example, re-entry attack, uh, authorization errors, input validation not in place, buffer also DOS attack, etc. So for example, there is this damn vulnerability 5 which lists all those vulnerabilities and how to check them. So you can use that. You can also use some tools, but there are very few limited tools in case of smart contracts which you can use, and they will probably only show you 5 to 6 vulnerabilities, very basic ones. So it's all about you polishing your skills and learning solidity and developing your own contracts, and then you can be able to spot errors in other smart contracts. No, the methodology for smart contracting is not the same for pen testing, in the sense that there is a target and you're trying to enter it through ports and services. In smart contracts, you're trying to find the error in the code because the code is available on the internet. You copy and paste it into Remix IDE, and then you use some malicious codes that are also available, for example, reentrancy attack, buffer overflow attack, and then you try to attack that contract with your malicious contracts, and then try to see if you're able to do it, and what are some of the changes that you might do in the malicious codes that might help you do attack the smart contracts that you're testing. So it's a bit different than normal or conventional pen testing.
Right. So thank you, Waqar. As we wrap up this webinar, I hope our audience will find this webinar very useful and informative. Thank you all. Thank you for
All right, thank you for
joining us
having me.
today. Thank you. And we hope to
Bye.
see you again at our next
Yes,
webinar.
yes,
Have a great
we
day.
can have a practical one. Yes. All right. Bye bye.